morning everyone. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter thermodynamics and we are in the topic entropy. In the entropy we are discussing PYQ of JEE main. Here is one question given in 2023 JEE mains examination. Let us see that question. 1 mole of an ideal gas at 350 Kelvin is in a 2-liter vessel. Okay, so here you are having ideal gas. Let us take ideal gas enclosed in a cylinder with a piston where it is at a temperature of 350 Kelvin and volume 2 liters. 2 liters of thermally conducting valves. So these valves are thermally conducting, which allows heat to flow through the valves. Such valves are called as what? Thermally conducting valves, which are in contact with the surroundings. It undergoes isothermal reversible expansion. What process is it is undergoing? A reversible process. Reversible. For reversible process, we have studied that delta S total will be equal to 0. Delta S total will be equal to 0. That means delta S total means delta S system plus delta S surrounding is equal to 0. Total change in the entropy, delta S total means total change in the entropy. Total change in the entropy means change in the entropy of the system plus change in the entropy of surrounding. So for a reversible process, what is that? Change in the entropy of the system plus change in the entropy of the surrounding will be equal to 0. Okay. It undergoes isothermal reversible expansion. It is undergoing expansion from 2 liter to 3 liters. So volume initial is equal to 2 liters, volume final is equal to 3 liters. So when it is expanded, automatically the volume increases. If the volume increases, there will be more space between the molecules, so that the molecules move randomly. When the molecules move randomly, their randomness increases. When the randomness increases, entropy increases. Entropy increases. So as this process is expansion process, what process is this? Expansion. During expansion, randomness increases. So delta S of system will be positive. That means change in the entropy of the system will increase. Change in entropy of the system will increase due to more intermolecular space of intermolecular spaces. The molecules find more space to move. They move randomly, so entropy increases. Right? Against a constant pressure of 4 atmospheres. Here against a constant pressure of 4 atmospheres, this is happening. The change in the entropy of the surroundings. Asked is surroundings. If you calculate system, then delta S surrounding will be what? Delta S surrounding will be equal to minus delta S system. Okay, because delta S system plus delta S surrounding will be equal to 0. If you want delta S surrounding, then that will be equal to minus delta S system. Okay, so let us see here. From first law of thermodynamics, we know that from first law of thermodynamics, we know the formula delta U is equal to Q plus W. So this process is happening at a constant temperature. So this is isothermal process. What is this process? Isothermal process. In isothermal process, we know that delta T, that is equal to T final minus T initial, which is equal to 0 because T final is equal to T initial. Isothermal, same temperature. Final temperature is equal to initial temperature. And we know that we know one formula, delta U is equal to NCV delta T. So delta U is equal to N into CV into delta T. Now only we have seen that it is 0, that is equal to 0. So delta U is equal to 0. So 0 is equal to Q plus W. So Q will be equal to minus W. U is equal to minus W. And in isothermal process, we have studied that work done reversible is given by the formula minus 2.303 nRT log V final by V initial. We have already derived this formula previously. Work done in isothermal reversible process is given by minus 2.303 nRT log V final by V initial. And here we have already seen from the equation 1 or formula 1, what is that? Q is equal to minus W. So Q will be equal to minus W means minus of 2.303 nRT log V final by V initial. Okay. So minus into minus, you get a plus 2.303 nRT log V final by V initial. This is what Q reversible. Q reversible. And we know that delta S is equal to Q reversible by T. That is equal to plus 2.303 nRT log V final by V initial by T. So T cancel. Then what do you get? Delta S. This is all happening in system here. 2.303 nR log V final by V initial. That is equal to. Okay. So 2.303 number of moles given. See here, number of moles given is 1 mole. How many moles? 1 mole. And volume is changed from 2 to 3. So V final is 1 mole. R value given already 8.314 joule per mole per Kelvin into log V final is 3 liters by V initial is 2 liters. Okay. Then what do we get? That is equal to 2.303 into 8.314 into log 3 by 2. You can write it as log 3 minus log 2. So what you get is 2.303 into 8.314 into log 3 is 0.4771 minus 0.3010. So delta S of system, we are getting approximately 3.37 joule per Kelvin. Okay. So then what will be delta S surrounding? Delta S surrounding, we have seen that minus delta S system. That is equal to minus 3.37 joule per Kelvin. Right? So for example, let us take here this container is system and this is surrounding. And this is the wall which is allowing the flow of heat. Right? So it is doing work, it is expanding. When it is expanding, it is absorbing some Q from the surrounding. So when it is absorbing some heat energy from the surrounding, heat energy of the surrounding decreases. When the heat energy of the surrounding decreases, automatically its entropy decreases. That is the reason why we got entropy of the surrounding as minus 3.37. As it is integer question, delta S surrounding will be equal to 3 joule per Kelvin. Okay. So what is the question asked? The entropy, the change in entropy, delta S of the surrounding is 3. Okay, minus 3. If it is only magnitude, then we have to go for 3. Right? So let us see similar type of question. Similar type of question. So helium gas, what is that? Helium gas weighing 16 gram is expanded reversibly from 1 atmosphere to 1/10 of its original pressure. So what I can take here, there is helium gas in this cylinder, it is enclosed. How much it is there? 16 grams of helium. So number of moles of helium will be weighed by molecular weight, or here it is only element. So what you can write atomic weight, gram atomic weight. Here weight is given 16 grams, by helium gram atomic weight is 4 grams. So number of moles will be 4. So initial pressure P initial is equal to 1 atmosphere. P final. So when it is expanded, when the volume is increasing, automatically pressure decreases. So P final is 110, 1 by 10th of 1 atmosphere. That is equal to 1 by 10 atmosphere. 1/10 of its original pressure at 30 degrees centigrade. The change in the entropy of the system. In this, now the question asked is what is the change in the entropy of the system? Again, the process is happening at a constant temperature of 30 degrees centigrade. So it is isothermal. And already in the question it is given that it is a reversible process. So isothermal reversible process. Okay. Isothermal reversible process. In isothermal process, from Boyle's law, we have seen that Boyle's law, already it is mentioned that you have to assume that helium gas is ideal gas. Boyle's law applicable for ideal gas. We know that P initial, V initial is equal to P final, V final, because from Boyle's law at constant temperature PV is equal to constant, we have studied. Okay. Now if P final, V final. So V final by V initial gives you what? P final by P initial by, what do you get? P initial by P final, right? So from Boyle's law describes the relation between pressure and volume at constant temperature. Okay. Now what is the question asked? Before we have seen, in the previous problem we have seen, for isothermal reversible process, delta S of the system, delta S is equal to 2.303 NR, okay, NR log V final by V initial. As volumes are not given, as pressures are given, we can convert this volume into pressure. Then what do we get? 2.303 NR log, instead of V final by V initial, I can write what? P initial by P final. P initial by P final. Okay. Then what do I get? 2.303 NR. So Number of moles, already we have calculated that it is 4 number of moles. So 4, and R value already given. What is that? 8.314 joule per mole per Kelvin, right? Into log P initial is 1 atmosphere, P final is 1 by 10. So that is equal to, here mole we have, here 4 moles, mole gets cancelled, then 2.303 into 8.314 into 4 into log 10. Log 10 is equal to 1. So 2.303 into 8.314 into 4 joule per Kelvin. So then if you calculate, so what answer you are getting approximately? So approximately you will get 76.57 joule per Kelvin. So nearest integer is 77 joule per Kelvin. So that is how we solve the questions on such type of questions when they are asked to calculate the entropy. So we have to see whether they are asking entropy change of the system or entropy change of the surrounding. Here they are asking about the entropy change of the surrounding system. So we have to go with the, this is all happening in the cylinder enclosed by a piston. So that is considered to be system. As it is expanding, the change in the entropy will be positive. If it is undergoing compression, no doubt the change in the entropy of the system will be negative. If I ask, this is a reversible isothermal process, if I ask delta S of the surrounding, then we know that delta S of system plus delta S of surrounding is equal to 0. So delta S of the surrounding will be equal to delta S of the minus delta S of the system. Then it will be equal to minus 77 joule per Kelvin. Minus 77 joule per Kelvin. But here the question asked is only delta S of the system. Okay. So it will be how much? Approximately 77. Nearest integer is 77 joule per Kelvin. Okay. Answer. Thank you for watching. We will meet